China just found buried evidence of an ancient ocean on Mars, hidden 30 feet underground for 3.5 billion years. Their Zhurong rover uncovered what could be the first real proof that Mars once had beaches, waves, and potentially life. But here's where it gets interesting. Elon Musk just responded, claiming SpaceX's approach to Mars makes this discovery look like yesterday's news. Is he talking about landing humans there before anyone can study these pristine ancient sites? Or does SpaceX have something else planned that could revolutionize how we explore the red planet? What exactly makes Musk think his solution beats finding actual evidence of Martian oceans? Here's what actually happened that's making SpaceX rethink everything. On July 23, 2020, while most of the world was focused on pandemic headlines, China launched something that would quietly change our understanding of Mars forever. The Tianwen-1 mission lifted off from Wenchang aboard a Long March 5 rocket, carrying the Zhurong rover toward a destination 202 days away. But this wasn't just another Mars mission. China was attempting something only NASA had successfully pulled off before, a complete 3-in-1 mission. Orbit, land, and rove, all on the first try. No test runs, no practice missions, just straight to the hardest challenge in planetary exploration. The stakes? Enormous. Mars has destroyed more spacecraft than any other destination. The thin atmosphere is thick enough to burn you up, but too thin to slow you down properly. It's like trying to land through fog that's also on fire. Russia lost every Mars lander they ever sent. Europe's Schiaparelli crashed at 300 miles per hour. Even NASA's success rate hovers around 50%. So when Tianwen-1 reached Mars orbit on February 10, 2021, that was just the beginning of the real test. For 3 months, the orbiter circled Mars, scanning the surface below. Engineers were looking for something specific, the perfect landing site in Utopia Planitia. Why there? Because decades ago, NASA's Viking 2 had touched down in this region and found something puzzling. Sediment patterns that didn't quite make sense. Rock distributions that seemed organized, almost like something had sorted them. But Viking 2's instruments couldn't dig deep enough to know for sure. Now here's where China made a calculated gamble. Instead of choosing a safe landing site with flat, boring terrain, they aimed for the exact spot where the geological mysteries were deepest. On May 15, 2021, at 4 a.m., Beijing time, Zhurong separated from its orbiter and began the 7 minutes of terror. Hitting Mars' atmosphere at Mach 3, heat shield glowing, parachute deploying at Mach 2, slowing the descent but not nearly enough. At 1.5 kilometers up, everything happened at once. Protective shell jettisoned, main engines igniting. Then something remarkable. At just 100 meters altitude, Zhurong stopped. Completely. It hovered there using laser 3D imaging to scan the ground below, looking for the safest spot. Not the planned spot, the safest spot. In real time. With a 20-minute communication delay, meaning Earth couldn't help even if something went wrong. The rover touched down so gently that dust barely rose from the landing legs. China had just pulled off what many Western engineers thought was impossible for a first attempt. But the real discovery was still buried underground, waiting. Zhurong rolled off its lander on May 22nd and immediately started doing something different from any previous Mars rover. Instead of just analyzing rocks on the surface, it was equipped with ground-penetrating radar that could see 80 meters down. That's deeper than a 20-story building is tall. And when those radio waves started bouncing back, they revealed something that made geologists around the world stop and stare at their screens. About 10 meters underground, the radar detected layers, smooth, parallel layers of sand, running at a 15-degree angle, rising toward a rocky cliff. The pattern was unmistakable to anyone who studied Earth's geology. These were beach deposits, ancient shoreline formations, the kind that only form when waves lap against sand for millions of years. Not thousands of years, not hundreds of thousands. Millions. Think about what that means. For those layers to exist, Mars needed flowing water, rivers feeding into an ocean, waves sorting sediment grain by grain, tides moving sand up and down beaches, weather patterns stable enough for all of this to continue, season after season, year after year, millennium after millennium. This wasn't just evidence of water on Mars. This was evidence of an ocean that lasted longer than many species have existed on Earth. But here's what makes this discovery almost impossibly lucky. Those beach layers should have been destroyed. Mars has been bombarded by asteroids for 3.5 billion years. Volcanic eruptions have resurfaced huge regions. Dust storms have scoured the planet's face countless times. Yet somehow these ancient beaches survived, protected under 10 meters of debris. It's like finding a perfectly preserved dinosaur footprint under your basement, except the dinosaur lived on another planet and the footprint is an entire coastline. The data kept coming. Zhurong traveled 1.9 kilometers, far exceeding its planned 90-sol mission. By August 2021, it had completed every scientific objective. By September 2022, it had transmitted 1,480 gigabytes of data. Weather reports from Mars, magnetic field readings, mineral compositions, high-resolution images of ancient flood channels. Each dataset building a more complete picture of what Mars once was. And that picture is staggering. Utopia Planitia wasn't just wet, it was an ocean floor, possibly connected to a northern ocean covering a third of the planet, with coastlines, beaches, possibly river deltas. The kind of environment where, on Earth, life doesn't just survive, it thrives. Tidal pools concentrating organic molecules, shallow waters warmed by sunlight, protected coves where chemistry can experiment with complexity. China's scientists published their findings with careful scientific language, but the implications screamed from every graph. Mars was habitable, not might have been, was. For millions of years, during the same era when life was taking hold on Earth. Then came the Martian winter of 2022. Temperatures dropped to minus 100 degrees Celsius. A massive dust storm rolled through Utopia Planitia, coating everything in its path. Zhurong entered hibernation mode in May, programmed to wake when its solar panels could generate 140 watts, and its core temperature rose above minus 15 degrees Celsius. December came. No signal. January 2023. Still silence. Orbital images showed the rover buried under dust, solar panels dark. The mission officially ended, but its legacy exploded into the scientific community. Because now everyone knew, Mars has secrets buried just beneath the surface. Ancient oceans, preserved environments, possibly biosignatures waiting to be discovered. And suddenly, the race to Mars wasn't just about planting flags anymore. It became about who could dig deepest, drill furthest, and bring samples back to Earth for analysis. This is where the entire Mars exploration strategy splits into two dramatically different paths. China just announced Tianwen 3 for 2028, a sample return mission. Land on Mars, collect rocks from these ancient ocean sites, launch them back to Earth, study them in laboratories with equipment that could never fit on a rover, search for fossilized microbes, analyze isotope ratios, look for organic molecules that could only come from living processes. The careful, methodical approach, the scientifically pure approach. But there's another philosophy emerging. One that says the best way to explore Mars isn't with robots at all, that the real breakthrough won't come from bringing a few kilograms of rocks back to Earth. It'll come from bringing humans there. Hundreds of humans, with construction equipment, drilling rigs, and the ability to make decisions in real time instead of waiting 20 minutes for every command from Earth. This approach argues that Zhurong's discovery, as groundbreaking as it is, took nearly 2 years to find beaches that a human geologist would have spotted in an afternoon walk. That sample return missions will bring back maybe 500 grams of carefully selected material, while human missions could process tons of soil per day. That the question isn't whether we should study ancient Mars oceans, but whether we should do it with billion-dollar robots moving 100 meters per day, or with geologists in pressurized rovers moving 100 kilometers per day. So, which philosophy wins? The one that treats Mars as a scientific preserve to be studied carefully from orbit and with sterile robots? Or the one that sees Mars as humanity's next home, where discovery happens as a byproduct of settlement? Here's the conclusion that Elon Musk recently made clear during a SpaceX presentation, and it's controversial. He looked straight at the camera and said, China's approach to Mars, while scientifically impressive, is solving yesterday's problem. Finding ancient oceans is fascinating for textbooks, but it doesn't answer the urgent question: can humans survive there now? His argument cuts deep. Tianwen-3 won't launch until 2028. Samples won't return until 2031. That's 9 years to potentially confirm what Zhurong already strongly suggested. Mars had water. Meanwhile, SpaceX's timeline puts boots on Martian soil by 2029. Not to collect samples, to stay, to build, to answer the survival question in real time with real stakes. But here's what Musk isn't saying publicly. If SpaceX lands first in regions like Utopia Planitia, they could contaminate the exact ancient ocean sites that hold the best evidence of past Martian life. Earth microbes on spacesuits, construction dust settling over pristine geological formations, drilling operations punching through those carefully preserved beach layers that survived 3.5 billion years, only to be disturbed by the first human habitat foundation. China's finding beaches buried under 10 meters of protection. SpaceX wants to dig 100 meters down for underground cities. See the conflict. We're racing toward a moment where humanity has to choose. Do we study Mars first, then settle it? Or settle it first and hope we don't destroy the evidence of ancient life before we even know it's there? Drop your thoughts below. Should SpaceX slow down to let science happen first, or is human settlement the real science we should be doing? Hit subscribe to New Space Review for more Mars coverage, and smash that like button if this changed how you think about the race to Mars. Share this with anyone who still thinks the space race is just about getting there first. Because it's not. It's about what we do when we arrive.